Hello. Either you want to look at the distant star or watch your neighbor, the neighbor galaxies. You need some devices that help you to make things bigger, so it looks closer to you, such as telescope, binoculars, or monoculars, so either of them. So I'll teach you today how to make one and the simple physics behind it. First, let's talk about lenses. We have convex lens or converging. That's how it look like. And you can see the light that goes in and they are focused behind it. The point they meet each other, these ray lights, we call them the focal point, and the distance between the lens and that point is the focal distance. The other type of lens we have is called concave. Concave lens or diverging is spread out the light, so the light comes from a distance and is spreading out. If we mix these lenses or just using two convex together, we can make things look bigger and therefore looks like it's closer to us. So the first one I want to show you is using two convex lenses. Convex lenses can have different thickness, means they have different power. The best lens we have is in our eyes because it can change its thickness and therefore focus on the items either close by or in a distance. If you look at the things in a distance, your lenses are more relaxed. That's why they say if you want to rest your eyes, look at the distance, something far. When you read books or you're on your devices for a long time, that would tire your eyes. Okay, so here first we're gonna make a telescope. Telescope is the simplest one. It's made out of two convex lenses together. So that is how it looks like. We have the eyepiece, usually is a smaller one, and the bigger one is the objective lens. That's where the light comes from a distance, and that's where your eye is going to be to see the things bigger. However, the image that you get is going to be upside down and laterally inverted. It doesn't matter if you look at the stars, because they don't have a head and toes, so even if it's upside down. But if you're going to look at them in something at a short distance, therefore you're gonna see everything upside down. So that's gonna be a problem. However, it's possible. I'll show you how to fix that. To build the simple telescope, you need two convex lens. Place the first one here in the ruler first. I'll tell you why. With like a blue tag, like how I did it here. And the other one, where to place it, because you don't know the focal point of these lenses. So the second one, you look at some object in a distance far, and you move the second lens, this one, back and forth until you get a clear image. And that's the place you keep your second lens, and obviously put that in a tube like this, and it's done. But that's the fixed one, so you cannot change the distance between these two. However, the best one will be the one that you can adjust it. So depends on how far the object is from you, then you can adjust it like this one. So one convex lens, another one, and when you place these two to each other like this, you can change the distance between two lenses, therefore get a clear image. So that's how it looks like. As I said, the image that I get is bigger, but it's upside down. I'll tell you how we can fix the issue of having a upside down. But before that, I'll tell you about making a monocular, and therefore if you put two of them together, become binocular. So monocular is made out of what the eyepiece is concave lens, diverging, and the other side is convex lens. Here, this is eyepiece, and I'm going to use one of this. The lens needs to be closer, so if I place it this way inside, so I can have a shorter distance. Okay, now it looks much better. Nice. And this one, the image is not upside down, it's not laterally inverted at all, as you get an upright, straight image. Perfect. Now, how would we fix this one? We want the telescope. Nowadays, what they use either can be a mirror or the best one is the prism. If we have two prism, I have stuck these two together with the tape. Two prism. When the light goes in from this side, you have a total internal reflection, bounce back to the other one, and comes out from the other side top. The light that comes out from here is upside down, means it would correct your upside down image, make it upright. And where does this goes? Goes between these two lenses, somewhere around the focal point of your eyepiece, which is kind of for this one here. So when you look through this now here, I see everything upright. Hey, it's no upside down anymore. And that's how it works. Physics is amazing. I love it. I'm gonna make my student to make it, see how good they are.
Telescope using two convex lenses, and when we put them together, this is what we have.
Looks like the one I made myself.
Because you used ours.
Prove it.
Well, it's right here.
Okay.
So it makes a telescope.
Shall I try it in the camera? Let's.
Is it working?
Right.
Oh, right.
This is our design. I'll let you know.
Nice intro.
So we made a telescope out of two convex lenses. We're still going to cut this part, but it is going to make it like the things you look at bigger and clearer. The difference between the distance between.
Is it adjustable or not?
No.
No.
Because the focal point or the sweet spot is 15 centimeters.
Okay,
The
so you found the
distance
focal
between
point.
15 centimeters. So whenever you,
Brilliant. Who taught you how to find the focal point?
Mr. Yazdan.
This cool guy.
Bill Nye.
Bill Nye.
We made a telescope with two convex lenses, and we put one roll in another one, so we can zoom it in or out on the object you want to see.
Brilliant. So how does it adjust? Can you just move
We
it?
can just do like
Oh, can
that.
you bring it closer and show it? Oh, brilliant. Excellent. Well done. Good job.
So we made a monocular. This is the convex lens, and this is the concave lens, and this is where we look through it. And it is adjustable.
The other way around.
Yeah, that's where we end. And actually, a convex lens is the human eye is a convex lens as well,
That's correct.
because it's curved outwards, not inwards.
That's correct.
And that's adjustable, so you can like zoom in and out.
Brilliant. Thanks so much. What if you want to look at something close and it's not far? Magnifying glass. Simple. And also you can burn your own hand holding in the sun, make the sunlight get focused, the focal point on your hand, and you burn your hand. But I don't know, why would you do that? I've done that a lot before, but you don't do it. Do it, it's fun. You can even burn the paper. Don't do it indoor, please do it outdoor. Don't do it. Don't try this at home. Safety first. Alright, thank you for watching my video. I hope you learned something cool today and make your own telescope. See you guys, bye.